Hi, I'm Grace from the Ningnan University Libraries. Welcome joining today's JULAC webinar, Achieving Academic Success with Web of Science. This webinar is part of our JULAC webinar series organized by the Learning Strategies Committee. It is actually a subcommittee from the Joint University Librarians Advisory Committee, JULAC. Some of you may have heard the name of JULAC when applying for the JULAC Help before. Now, let me hand over to the chair of the Learning Strategies Committee, Mr. Christopher Chan, the University Librarian from the Hong Kong Baptist University Library, for a few words before we start. Chris?
Thanks, Race. Could you let me start my video? I mean, I'll continue with my remarks. It says my host has stopped the video, but I'll keep going just in the interest of time. Good afternoon, everyone. Chris here, University Librarian at Hong Kong Baptist University. Thank you for joining us today for this webinar on Web of Science, a long-established publisher, independent, a global citation database. I'm delighted to welcome our speaker, Rachel Mangan, a solution specialist from the Web of Science group at Clarivate. And before we dive in, I also wanted to extend my heartfelt thanks to members of the JULAC Learning Strategies Committee, and particular thanks to Race Koo of Lingnan University Library, who's serving as the virtual host for this event. Their efforts are very much appreciated. So in today's session, Rachel will introduce the Web of Science platform and showcase its powerful features. You'll learn various searching techniques to discover quality literature in your field, apply analytical tools to identify key research insights, and understand how to measure research impact responsibly. So librarians are constantly focused on how to enhance the research experience of our students and faculty, and this session will certainly be of great benefit in that regard. So let's get started. Thank you, and over to Rachel.
Hello and good afternoon. Can everyone hear me?
Yes, loud and clear.
Oh, great. Okay, thank you. So first of all, I would really like to thank you for inviting me to present the Web of Science today. I'm located all the way in London, so for me it's early in the morning, and I appreciate that it's the afternoon where you are. So yes, I'm going to be presenting the Web of Science platform and how we can use this to discover relevant literature in our specific research topics. So let me see that I can share my screen. Okay, so the theme of today's training session is how to achieve academic success using the Web of Science. So my name's Rachel Mangan, I'm in the customer success team, and it's my pleasure today to present in this wonderful tool that we can use to help us find the best literature in our research topic. So first of all, I'm going to kick off with an introduction to the Web of Science platform. The platform is the gateway to access a number of databases. So I just want to explain what is available on the Web of Science platform. And then we're going to be focusing on the database called the Web of Science Core Collection, which is our flagship discovery solution. So within the Web of Science Core Collection, we're going to be looking at different techniques in order to discover quality literature in whatever our research topic is. So we'll be looking at traditional keyword searching, applying AI keywords, etc., using citations. Then I'll be showing you how we can apply what we refer to as our analytical capabilities to identify key research information or key research insights, such as which organizations published this literature, in which journals are these results published. Then we'll be talking about the concept of research impact. So how do we identify research that is impactful, but also how can we better understand why research is cited, okay, the intention of citing previous research. So that's an interesting feature of the Web of Science, and I'm going to be covering how we do this in the Web of Science. We'll also be looking at how you can apply sort of like maybe criteria or filters to your search in order to locate quality resources based on your specific requirements. So, for example, maybe you are required to publish in an open access source. So I'll explain how we could achieve that in the Web of Science. Then we'll be also looking at being able to identify which are the most impactful journals in our particular topic by applying various journal metrics that help us assess or gauge the performance of a journal. And then finally, I'm going to be showing you a tool that isn't inside the Web of Science, but it's one of a Clarivate solution that you can access called the Master Journalist. It's not, sorry, the Manuscript Matcher, and it's on the Master Journalist. And what this tool does is it helps identify highly relevant journals that publish in our research area, and these therefore could be possible candidates to publish your manuscript that you want to get published. Okay, and then we'll have some time for Q&A. Okay, so kicking off with that introduction, what is the Web of Science, and obviously what is it primarily used for? So the Web of Science platform can be considered as a container or a gateway to access various databases that index scholarly literature. Okay, so what you can see in the visualization are all of the databases that are hosted on the Web of Science platform today. Okay, regardless of your subscription. Okay, so this is the full or complete range of databases that are available on our platform called the Web of Science. So just to cover them very briefly, we have speciality databases, we have regional collections, we have hosted content, and we have databases that go beyond what we call published literature. So there is a trend that has been developing over time, and that is, research is branching out. Research is no longer, researchers are no longer restricting their search just to content from scholarly journals. We are trying to, let's say, surface all of the diverse outputs that there are in scholarly communication, and that is reflected in the Web of Science database today. We have dissertations and theses, we have preprints, we've got data, we've got awarded grants, and we've got patents. So I'm going to be touching more about this on how we should scale up our searching and include all of these diverse outputs to get a better, more rounded flavor of our research topic. So the platform is the gateway to access many databases, but what we are focusing on today is the database that forms the nucleus, or effectively the core of the platform, which is the Web of Science Core Collection. So that is its official title, the Web of Science Core Collection. And this database consists of a series of individual citation indexes that index the primary channels in which research ideas are disseminated. And that is via journal content, book content, and preceding content. Okay, so those are the only sources that are indexed by the core collection: journals, books, and conference proceedings. So that's the database we're going to be focusing on today. So what I want to do now is just talk a bit more about the key characteristics of the Web of Science Core Collection, so that you understand the value of this database. So I'm just going to go to this slide here. Okay, so the Web of Science Core Collection, as I mentioned, indexes journals, books, and conference proceedings. And the journals are indexed by 4 journal indexes: the Science Citation Index Expanded, the Social Science Citation Index, and the Arts and Humanities, and the Emergent Sources. So 4 journal indexes. We then also have book indexes and conference proceedings. So if you want an idea of some numbers, in the core collection, if we talk about the journals only, there are more than 22,000 journals. And on the screen there, you can see how many journals are currently indexed by the individual citation indexes. So the Science Citation Index Expanded is the largest, with just over 9,000 journals. Then there's Social Science Citation Index with just over 3,000 journals. Arts and Humanities just over, or nearly 2,000. And then the Emerging Sources currently indexed in over 8,000 journals. Now, what is unique about the Web of Science core collection, and that something that distinguishes us against in comparison to other similar databases, is that we are a publisher neutral database. What does that mean? It means that Clarivate is an independent organization. We have no, let's say we have partnerships with publishers, but we have no interest or let's say business in the publishing market. Our selection of sources is based purely on a set of criteria that we have established to select journals of highest quality and impact. So it doesn't matter who the publisher is, it doesn't matter what country that journal comes from, as long as the journal meets our standards, it will be indexed in the Web of Science core collection. So this gives us a great advantage in the market because we're not biased, we don't have any favoritism, we are completely neutral. Now, the Web of Science core collection is your go-to discovery tool because it is a multidisciplinary tool. Now, although it has the word science in the title, it is more than just science. It goes beyond science. You can see we've got social sciences and arts and humanities. So amongst all of those citation indexes, we have 254 subject categories. So it truly is a multidisciplinary database. So there will be, I'm very sure and very confident to tell you, there will be literature definitely in your subject area. Okay, so no matter whether you're in arts and humanities or you're in the STEM sciences, there will be content for you in this database. Aside from the neutrality, the size of the database, let's talk about the quality of the bibliographic information. So another unique characteristic is that the Web of Science core collection data is known as being of the highest quality in comparison to other similar databases. We have applied consistent indexing policies ever since the Web of Science existed, and it has been around since the early 1960s. We index the data ourselves. We don't ingest data from third parties. So we have a very large production area where the indexers, humans, this is a human process, index the bibliographic information. So our high standards are applied, standard rules are applied, and therefore the quality of the bibliographic information is extremely high in the Web of Science. We index all author names, we index funding information, all of the addresses, all of the bibliographies, the cited references, and we also improve data. So for the addresses, particularly the organization part of the address, we improve this by consolidating all of the different variants into one preferred name. So we've done this for over 19,000 organizations. We also unify funders, we unify publishers. And this means that for you, the benefit is that you can quickly obtain the best possible results for that entity, whether it's an organization or a publisher or a funder. Okay, so just want to touch upon the selection, because this is important for you to understand. So our selection is based, is conducted by an in-house team of editors. They are Clarivate employees, so they don't have parallel roles in the publishing community or have other conflicts. They are 100% employees of Clarivate, and it's their sole responsibility to select the sources. They have a wealth of experience. They speak the major global languages. And so, yeah, no affiliations or interest with journals or publishers. So complete neutrality. So we select sources based on certain criteria, and with regards to the journals, we use a set of 28 criteria. And the Web of Science core collection individual databases are engineered, should we say, based on the selection. So if a journal meets the 24 quality criteria, it will be indexed in the Emerging Sources Citation Index that has, over 8,000 journals. If the journal meets the 24 quality criteria plus the 4 impact criteria, it will be indexed in what we call our flagship citation indexes, the Science Citation Index Expanded, the Social Sciences, and the Arts and Humanities. Now, we continuously evaluate content, existing content and new content. And there is movement between the collections. So if, let's say, a journal from the flagship citation indexes does not meet the quality, the impact criteria anymore, it can be demoted into the emergent sources as long as it still meets the 24 quality criteria. If a journal does no longer meet any of the criteria, then it can be removed from the Web of Science. And there is a deselection process that happens on an annual basis. So what does this actually mean for you, the end user? Why is this important? Well, in today's publishing landscape, there is an increase in the pollution of what we refer to as unethical or bad practices in publishing. So, for example, what we call hijack journals or predatory publishing journals. So there are an increasing number of questionable journals, okay, and it is increasing as time goes by. Now, we don't want our database to be diluted by such sources, because this means that the results, the literature that you will be searching will not be of high quality, and it can be, as I said, questionable. The validity, the reliability is questionable. Now, that doesn't make a very good discovery tool. What you want is high quality, reliable, trustworthy information, so that the results are applicable. So by applying this filter, let's call it the editorial process, we only select high quality sources to be in the Web of Science core collection, which means the benefit for you is that you can trust the sources and obtain high quality results. Okay, so just going to go back to this slide and then we'll go searching. So as I said today, the Web of Science platform has expanded to go beyond traditional scholarly publications, and we now include a diverse range of scholarly outputs in the form of dissertations and theses, preprints, conference papers, data sets, patents, books, and grants. And so all of these different formats of scholarly outputs are can be considered important and relevant, and they can be all searched on the Web of Science platform. So this is my recommendation for you. Search in the core collection, of course, but don't just limit yourself to the core collection. You can search in what we call all databases and search all of the diverse outputs that you have within your subscription, and include that in your search and discovery. Because it could be that there is another type of source, whether it's a preprint or could be dissertations and theses, that might have valuable information to provide you with good insights into your research topic. Okay, so we are going to start off here. Okay, so this is the Web of Science platform, and I'm going to talk about a few things that we need to prepare before we start searching. So first of all, I want to point out registration. So registration means that you create a Web of Science account. And it's a very quick and easy process. And why would you want to do this? Because it allows you to access additional workflow features of the Web of Science, saving your searches, creating query alerts, etc. So I do recommend that you register and create a Web of Science account to benefit from accessing these additional time-saving workflow features. So I'm not going to explain registration because it is very straightforward. I'm just going to simply sign in because I already do have a Web of Science account. So when you come to the Web of Science platform, the second thing that you need to do, aside from customizing your session, is to make sure that you are selecting the correct database to search. So you open the drop-down menu under the Documents tab, and you select the Web of Science core collection. Okay, so please make sure that that is selected. All right, so there are many different searches that you can perform in the Web of Science core collection. You open up the drop-down menu and you can see all of the different fields that you can search. So these fields actually refer to the data that we index from our sources. So for example, a topic search searches in the title, the abstract, and the keywords. It is the best search to locate relevant publications in your research topic using a keyword search strategy. But there are other searches available depending on what your particular use case is. You can search by affiliation. You can search by the title of the publication. You can search by publisher. You can search by Web of Science category, the 254 categories, or you can search by another one that's really popular is funding agency. Today, however, we're focusing on the traditional keyword search, the topic search. So at the moment, we use traditional keyword searching, okay, but we are moving towards natural language searching, and changes are going to be made to the search interface in the coming months, okay, but for the moment, it is traditional keyword searching. So you have your research question in mind, you know, what am I looking for, what is my topic, and you have to convert that into a keyword search. So I'm searching today for a very popular topic, which is artificial intelligence. So I'm searching artificial intelligence as a phrase, that's one term next to the other. And so for the moment, you need to insert your term in between what we call quotation marks. So this allows you to search for a precise phrase. Now, I'm also interested in artificial intelligence in the sector of education. So I've also included education. However, I want education to have context with artificial intelligence. Therefore, I've applied an operator called the near operator /4. And the number 4 means that there must be no more than 4 other characters separating artificial intelligence and education, which means that artificial intelligence and the word education will be found near to each other within titles, abstracts, and keywords. Okay, so the near operator is extremely useful to apply context and proximity to your search. So let's run the search, and you can see the number of results that we get. Okay, so first of all, my recommendation is to look at the results. Obviously, you're not going to look at all 2,000, but just look at the first page, and the highlighter will highlight the terms that you searched for. So it's a good way to identify whether these results are relevant to what you are searching. Okay, sometimes terms have different meanings in different research fields, acronyms, etc. So it could be that, you know, the relevancy is very low. So, you know, just scan the first page and look at the highlighted words and make sure that, you know, the results are relevant. Okay. So if you are happy with the results and you feel that they are relevant, you can proceed. So aside from traditional keyword searching, another technique that we can look at are using our AI generated keywords. So yes, we are adding the power of artificial intelligence to the Web of Science to help users search for more relevant information. So it's a carousel functionality which allows you to identify keywords from your search. Okay, so these are AI generated words that come from your search results, and you can add them to your existing search query to help improve your search strategy. So for example, let me have a look. They're all, I don't know, artificial intelligence in higher education. Let's say that keyword I think is useful for my specific topic. So there are 3 ways in which this keyword can relate to your original keyword search. We have or, okay, so or is my original term or this keyword, which would expand the number of results that you get. You click on the 3 dots and then you have the 2 remaining relationships. You have include, so it would effectively be and my original search and this keyword, or you've got exclude. Okay, so this is a new way in which we are supporting our users to discover more relevant content on the Web of Science by these AI generated keywords. Okay, but I'm not going to use them today. Okay, so that is so that now we've learned 2 techniques of searching: traditional keyword searching and our AI enabled keywords as well. You also have another AI feature which is on the right hand side. So spell that right. As you start to type a word, the tool suggests words that contain your characters, and again you can use these keywords to help improve your search strategy if you feel that they are useful. All right, so we've got our results. They are relevant. We've validated that. What else? What's the next step? Well, if we're new to this topic or we want to understand some let's say insights about this topic, we can use our very powerful analytical features such as refine results and analyze. So refine consists in a series of filters that allow you to obtain insights from the bibliographic data that we index. So for example, we can see what types of documents we have within the results. We can see who the authors are. We can look at, publishers, countries. We can see which are the countries of the author affiliations. We can then see as well the author affiliations. We can see in which journals these sources have been published. So it is a very long list of filters. I'm not going to open all of them, but they go all the way down till we get to the Sustainable Development Goals, which help us understand the classification of these results by the SDG goals. We also have another type of classification. We have our microcitation topics, which are an article level classification. So these help surface and identify the more specific, more detailed topics discussed by our results. So they are a useful way of focusing your search. We have 2 tiers of the citation topic hierarchy: the meso-citation topics, which are broader labels of topics, and then we've got the more detailed microcitation topics. I'm going to come back to these. So that is refine. Then on the just above the results, we have analyze results. So this is effectively the same exercise. We are still analyzing and our results, but it's the preparation is slightly different. So you open up the drop-down menu and you can again see the same fields as we have in the refine menu. There's absolutely no difference whatsoever. However, in analyzed results, you get the visualization, and the analysis is also presented in a table format. So if we go back to, for example, selecting countries and regions, we have the data, the analysis in a table. And what the analysis is doing, both in refine and analyzed results, it's simply counting volume, or also known as the number of publications. But what's useful about the table is that it provides an additional metric that puts the number of publications into context. So, for example, People's Republic of China with 494 results, we can therefore say with this metric that I'm highlighting has a market share of, let's say, 25% of the research. So it helps put the number into context. All right, so if this is my topic, I'm going to be, researching this topic, eventually writing a paper. I want my paper to be obviously published. I would want to identify which are the journals publishing in this topic. So analyze or refine by publication title. And here you can see the titles ordered by the number of articles. Okay, so at the moment, that's all we're counting. We're not counting or measuring impact or identifying strong performing journals. We're going to do that later. We're just looking at those sources that publish in our topic, rated or ranked by the number of publications. So, with this basic metric, we could say that maybe education and information technologies could be a good candidate because clearly they are publishing more content in this specific topic of interest. Okay. All right. So refine, analyze are very good to interrogate the research and obtain key insights into your research topic. So you better understand your topic, the producers, the sources, etc. Okay, moving on. All right, so let's talk about the value of citations and how we can also identify intention of citations. So being a citation database, one of the other metrics that we count, aside from counting publications, are the citations. So on the for each article on the right-hand side, you can see the papers times cited count. So it's impact. So if you don't see your papers ordered by citations, then just open up the drop-down menu and order them by citations highest first. So citations are a good indicator of measuring research impact, okay? So identifying strong or top research, seminal research, let's say, or so the higher the citations, the more impactful, let's say, that the research paper is. However, modern bibliometrics has established for some time that citations have to be what we say normalized or benchmarked, because citations are affected by three main characteristics: the year of the publication, the document type, and the category. So can we say that this paper with 715 citations is a very strong performing paper in its respective peer group? Well, let's interrogate. Let's look and explore. So you open up the record, and something that's new to help us better understand the paper's performance is this metrics panel on the right-hand side. So you open it up. Now, everyone sees the metrics panel, but the amount of data that you see does depend on whether you have a subscription to Insights Benchmarking and Analytics, which is our research intelligence platform. So what I'm going to show you is definitely what you will see. So what we do is we compare this paper's impact to other similar papers. And there are two levels of similarity. We compare this paper to other papers from the same category and papers from the same journal. Okay, so those are the two levels. So this paper and its impact is compared to papers from the same category, year, and document type. And if this paper's impact is, and we calculate an average or an expected impact. So if our paper's impact is above this expected or average impact, you will see a green triangle that says above average. If it's below impact, it will be a red triangle pointing downwards. So this is a good indicator to tell me whether this is a strong performing paper. And the same applies at the journal level. So we're comparing this paper's impact to other papers from the same journal, same year, same document type. And okay, again, you see the triangle in green or red. If it's green, the impact is above average. If it's in red, it's below average. Okay, so additional paper level information to help us better understand the impact of research. Okay, so helping us understand impact and how impact, has to be compared to how, a paper's impact has to be compared to other similar papers. That is the golden rule of bibliometrics. So that is a way of understanding the concept of impact. I'm just going to close this down. Okay, it's frozen. Okay, there we go. How else? So citations are a very good indicator of impact, but they don't reveal why the paper was cited. Okay, so why was this paper cited? What is its intention? What is its purpose? So if we go back to the results page, I'm going to now talk about a relatively new feature called enriched cited references. So enriched cited references is an improvement we made to the bibliography. Okay, so we started capturing this data from 2021 onwards. So that's why we have a quick filter, because not all Web of Science core collection content has this information. Okay, so it's a quick filter to help you limit your search to records that have this information. So let's open up a record, because the data is in the record, and you click on where it says enriched cited references. So what we are surfacing, what we are presenting is an analysis of the bibliography. So the bibliography is listed below, but we are presenting this information in a better way that helps identify the intention of why these items were cited. So in this visualization, we have an x-axis, which shows us the sections of the article. And then on the y-axis, we have what we call the citation class. Okay, so we have 5 citation class, which are fixed, and we classify the cited references into a citation class based on AI. Okay, based on another AI technique. So in this visualization, we can then identify what is the context of why the cited references were cited, how many times they were cited within the article, and in which section. So if you are looking for specific types of literature, maybe you're looking for literature that supports materials and methods, or you're looking for background information, you might want to look in the introduction. This helps you achieve that. So each little black dot, let me choose one that's got a title. Okay, this one, for example, shows me, if I click on the black dot, in which section was this article mentioned, what is the citation context, and how many times did it appear. If I think that this is an article or a citation that I wish to investigate further, you simply click on View in Text Mentions, and it will expose the citation in the bibliography. And then you can see a summary of which section was this citation mentioned, what is its classification, and then you also see the preceding sentence or phrase that came before the citation. So again, providing more background information to better understand the intention of why this particular item was cited by the authors. Okay, so this is a really interesting and useful information to help support your discovery needs. And then following on from that, we have a visualization called Citing Items by Classification, which helps me better understand how this paper has been cited in the citing literature. So, so it's got 253 citations, of which we have 909 with this enriched cited reference information. So not all citations will have the enriched cited reference information, but for those that do, we can then analyze how this paper has been cited in the subsequent citing literature. You know, how many has cited this paper with a background context or basis or support or differ or discuss. So when you are searching, if we go back to our original search for specific literature, not only can you sort by citations, but you can sort by citation class. So if you're looking for specific literature, for example, background literature or basis or support or differ or discuss, you can order your results by those citation classes. Okay, all right, so moving on. Just a few more items. So you're writing a manuscript, perhaps you have specific specifications that you must publish in an open access journal. Okay, maybe it's a mandate or a requirement. So to help you find quality sources based on your specific requirements, for example, open access, what you can do is you can use our open access data that we have in the Web of Science and focus your search on those open access sources. So for example, I can choose the quick filter open access, click on refine, and then we can analyze results and identify. If we go to analyze publication titles, these are publication titles. Actually, no, I've done that wrong. So sorry, let me go back. The open access sources, sorry, I shouldn't have chosen all of them. We need to select publisher open access. So it's the open access filter, and you choose gold, hybrid, and free to read. Then you click on refine, and then click on analyze results, and go to the publication titles. And then here we have, high quality, highly, meticulously selected sources that meet our publishing requirements, which is publishing in open access. Okay. So now let's talk about how we identify impactful sources in our topic, okay? Because so far, the only metric that we are evaluating our sources by is the number of publications. And this really isn't a meaningful metric to help gauge impact of sources, okay? This just purely measures the number of publications that these sources have published in our topic. So if we go back to the results page, there's a number of things that we can do. Now, journal performance, journal metrics are published by a different database called Journal Citation Reports, okay? And if you want to go to Journal Citation Reports itself, you just open up the drop-down menu and you can go to Journal Citation Reports. I think we will have time to do that. Or you don't even have to leave the Web of Science platform. If you just want to quickly assess a journal's impact, just simply click on its title and click on View Journal Impact. And we have this temporary window which publishes the key journal performance metrics published by the wider database journal citation reports. So I can quickly assess the performance of this journal. So I can see the journal's current impact factor, which is the key journal performance metric published by journal citation reports. And then we have the context. So this journal is in the, so all journals are assigned to a category or categories. This journal is assigned to education and educational research, and with an impact factor of 8.6 out of 760 journals. This journal, when those journals are ordered highest impact factor to lowest impact factor, this journal ranks number 4, and therefore it's in the top 25%, also known as Q1. So clearly, this journal is a good, impactful journal in education and educational research because it's in Q1. The other metric that we also make available is called the Journal Citation Indicator. This is a complementary metric. Journal assessment, journal evaluation should not, this exercise should not just be restricted just to one metric. Journal evaluation should employ a wide variety of metrics which are available in journal citation reports. Now, the impact factor is the classic journal evaluation metric, but it is no longer the only one, and we now advocate the best practice of applying multiple metrics to better understand your journal from a 360-degree point of view. So a few years ago, we launched another metric called the Journal Citation Indicator, which is a normalized metric. So remember, I talked about normalization, comparing like with like. This is what this metric does. It compares the publications in this journal to other similar publications and identifies whether the impact of this journal's content is higher, equal to, or lower than the expected impact. So so if the impact is expected, is therefore average, the value is 1, okay, of the JCI, it's 1. If it's higher than 1, and in this case we have a value of higher than 1, it's 4, it means that the impact is exceeding or above the expected impact. So what we can say is that this journal's content has an impact 4 times higher than the expected impact. So this, and it's being compared to other content in education and educational research. So again, it's a normalized metric, which is a more responsible way of assessing research performance. So use both. Don't just, we encourage you to use the impact factor, but also to use the journal citation indicator. If you want to explore this journal in further detail, you can go to the journal citation reports, and you can you just click on the many links that take you to the journal citation reports. This particular link takes you to this journal's profile in journal citation reports, and then you get more information about this journal's performance and impact, etc. So you can explore in greater detail if you wish to do so. But I think this information here is sufficient enough to make a quick and informed decision about a journal's impact. Okay, so moving on. The next thing I want to talk about is selecting high relevant sources to meet your manuscript requirements. So we've looked at many ways in which we can identify high quality relevant sources in our research topic. We've used refined results, we've used analyzed results, and now we've just looked at the integrated metrics from journal citation reports. Maybe even still, with all of this information, you find it difficult or challenging to identify the best source to publish your manuscript in. There is another tool that could also be really useful, and this is the last bit. It's not in Web of Science, it's in another solution that you can all access, and it's in what we call the master journal list. Okay, so we're going to quickly go there. And what this tool does, it's called Manuscript Match. Okay, it's extremely useful, and it helps researchers identify relevant sources. So you have to have a Web of Science account to access the manuscript matcher element. So and then what you do is you write in the I'm just going to type in artificial intelligence twice. So you have to provide some details about your manuscript, a title, an abstract, and then you just simply click on Find Journals. So we've built a very powerful matching algorithm that, based on your manuscript details, will then identify the matching journals. So it's a very good way to help you identify relevant journals. And these are all journals that are indexed in the Web of Science core collection. And you can apply the filters on the right-hand side. Perhaps you're looking for, again, open access sources, or you're looking for journals from a particular country or region, or journals that have a particular publishing schedule, or that are have a GIF for 2025. So lots of filters to help you, again, narrow down your results. If you then identify a source that you think is relevant, you can click on View Journal Profile, and then this will open up a lot of detailed information about this particular source. So, for example, in which databases and categories is this journal classified? We also present here the key journal metrics from the journal citation reports, okay, and some open access information if that is also a requirement. So I do recommend that you use this solution as a complement to the information we have already in Web of Science. And with that, I'm going to stop because we have finished the agenda. I know we are at time, so I'm going to stop sharing.
Well, thank you for that, Rachel. We did have one question that's been open for a while. It's about patents. Patents. And the question is, sorry, yes, my pronunciation, patents.
Yeah,
patents,
okay, patents. Doesn't matter.
Can I use the search engine to search for patents? So I think the question is essentially, yeah, go ahead.
So patents are available from a product, a database called Derwent Innovations Index. It's on the Web of Science platform, but it's not in the Web of Science core collection. So it's a different, separate database, and it does require a subscription. I'm not quite sure if it's a subscription as part of your collections, but to search patents, you do have to have a subscription to Derwent Innovations Index.
That's very useful, Rachel. So yes, to that question, check with your librarians to see if your institution does subscribe to that. I know for a fact, unfortunately, HKBU does not.
Okay.
But so for HKBU participants, I'm sorry, we don't have that patent search. But for others, check with your library. I think, as you mentioned, Rachel, we are at time. And I think that was the only open question that we had. So perhaps if there are no others, we can leave it there. But I did want to just reemphasize something you said right at the beginning, which I think is so important, that Web of Science is publisher neutral. As librarians, we do encourage researchers to think about that, because for other tools, which shall remain nameless, there's one I have in mind. There may be tools where the vendor is also a big publisher of journals, so of course they will say they don't push their own journals, but there's no way for us to know for sure. So it's good to know Web of Science. We can trust them because they have no other agenda. They are not sellers of journals. They are purely analysts.
The master journal list that I just showed you, the MJL, if you want to check what journals we index, you are completely transparent about our coverage and our selection. If you Google Web of Science journal selection, you'll get to the website that explains, how we select journals. If you want to know which journals are indexed in the Web of Science core collection, you just go to the MJL. So we are very transparent about our neutrality, our the foundation of the Web of Science, which is publisher neutral, and you can see which journals are indexed by the core collection.
Great. Yes, I just mentioned that because I think it's so important that we all understand that. Quite a few folks are asking about whether the recording will be available, and the answer is yes, it will. It will be posted to a YouTube link, which will be shared with everyone, with all registrants after the session. So with apologies for going 2 minutes over time, I think we'll leave it there and say thank you very much again to Rachel for your time. I know it's earlier in the morning for you, so have a great day.
Yeah, but not too bad.
Not too bad.
Yeah. Okay, great.
Thanks, everyone.
Thank you so much. Thank you.
Bye-bye.
Bye-bye. Bye-bye.